Okay, so today we are here to reintroduce the Wizly suite of solutions. We have grown into performance management, process mining, and ultimately we support decision management. So that's where we are heading in future. Really, Wizly is built using AI and machine learning, and it provides management an accurate and deep understanding of management information through the decision landscape of what we call the strategic, tactical, and operational management. Today, we are going to look at a problem statement. How do we gain insights into airline call center data to ensure process compliance, to find out recurrent issues, drill down to root causes, and to improve the airline operations in an easy and cost-effective manner. So processes are the link between the customer and the organization always. They are critical to the customer experience, and especially in the airline industry, they drive loyalty across the entire customer journey, from check-in all the way to, till you leave. Let's take a look at the design call center process. It starts with handling information requests as well as complaints, finding out solutions for all of them, but also balancing airline policy and customer needs. So let's see what insights we can find in this process. So that's me looking for insights. So insights are really a clear and deep and somewhat sudden understanding of a complicated problem or situation. It's critical for organizations to interpret process data to remain competitive, and very often key learnings are not readily visible. So what Wizly allows you to do, it allows for cyclical analysis of the data, starting with the log file, generating the flow models, examining alternate paths, and then running the insightful analytics on selected data sets. So this enables decision for possible solutions. Of course, the source of these, all these analysis is the actual truth, so the log files which have the workflow stages, and then of course the case attributes. So we look a lot into the case attributes as we go forward. So the first step is to actually visualize the executed process to perform what we call the discovery analysis, and this gives you the real state of the process diagram. We can then do a compliance analytic and then compare this with the actual design, and we can see steps which don't match. So steps in yellow were in the design but not in the actual execution. Steps in red were in the execution but not in the design. And of course, matching content you can see in the green, and we'll go through this. We can also look at the unique paths which are generated of the process and the cases which took, which went through each path. We can get some analytics on the percentage, but more importantly, for paths of interest or paths of concern, we can then drill down and run what we call contextual analytics, or analytics at the point of decision. And Wizly suggests these different analytics to the user depending on which part of the product or which part of the data they are in. And this helps the user to gain insights. So let's go through some of them. The first analytic we will look at is the correlation matrix. It's used to find hidden relationships, understand which highly correlated items you would focus on. So in this case, you're looking at customer satisfaction, overall customer satisfaction, and that between your response time and resolution time. And we can also visualize that in a box plot to understand what's similar, what is different, identify extreme values, and these are indications of process deviations. The next analytic is the matrix affinity analysis. This is to visualize relationships between any two attributes, for example, the different sectors of the airline and problem types, and to understand what types of problems occur together and what is the type of frequency they occur together in. We can chase relationships using what we call the DNA diagrams across multiple paths. We can, in this case, sector to issue types, and were they controllable or were they not controllable. And this allows us to drill down into them and then look at what we call linear analysis of relationships, which can be performed across multiple depths. Alternate paths are generated by the algorithms, and this is excellent for presenting cause and effect to management. The 4-box analytics is a visual representation showing clustering of relationships based on selected attributes. So in this case, we have the relationship between time cost and customer satisfaction, and it allows us to then focus on areas of concern or hidden areas of relationship. And finally, we look at what does the customer think. So the sentiment and semantic analysis allows us to analyze the customer feedback. Phrase data highlights common feedback threads. And of course, the sentiment, was it positive or negative? So we'll step into the demo. The purpose of the analysis is to improve airline operations. We'll take a look at the case data, and from here we will apply some analytics and see where we go from there. So I think this is pretty much done on.
And one of the things that we focused on was why you have these analytics, because often people are not familiar, particular customers that we have, are not really familiar with the analytics in detail. And the first question asked is, well, why would I do that? Okay, why would I have this analytic? So we focus a little bit more of why we have some of these analytics, okay, because we've used them for, oftentimes on projects for a number of years. Some of these analytics are not new, obviously. The machine learning stuff is based on statistical analysis, which has been here for 70, 80 years, if not longer. So there's a long history of some of these analytics. The neural net analytics are a little newer. Now, we've worked with neural net analytics for probably 25 years. 94? 94. That's 25 years roughly. And we find them to be extremely useful, especially the simple analytics. They're very useful.
Okay, so Wizly is really a suite of products. Today we are going to focus on the process part of it, since we are in BPM next. And first what we will do is we will take a look at the design diagram. So the design diagram of the call center, you have all the airline, let's say, processes there. The design diagram, as mentioned, you receive either information requests or complaints. If it's a new type of complaint, you find out if it's a valid complaint. If not, you tell the customer that he's just complaining. You identify a solution, and then so on and so forth. Now, we'll go and load up some case data here. So I've got 3,000 cases which were analyzed, which were generated over 2 days. Okay, and as we load the case data, and I'll quickly generate the actual cases, we'll just go through what the log files tell us. So the log files tell us that the cases, the different activities, and of course, being an airline, you find out what is the type, who is the customer who complained, who it was assigned to, the department, and then we have, of course, some numeric data like customer satisfaction, response resolution, cost per hour, and so on. So now the case data has been generated, so it's pretty fast. This is running off my local, and it's much faster when you run it in the cloud. It gives you some basic analytics about the total time for the case, the time it's taken between the different states, and so on. Of course, I can then go and generate the state data. So the state data again tells me the different workflow states, the state count, the percentage of transactions which went through, the different flow transitions which are there, how many transitions went through that, the total time, and the average time. But let's come to the flow model. So the flow model actually tells you the entire flow, the story of the process. Of course, you can do it even vertically also. I like to see it horizontally, so that's why that's my default. And you can get to see 3,000 transactions in and 3,000 transactions out. Now, the first analytic, what we want to do is we'll click on the Insights button, and we will do the compliance analytic. So what I will do is I will compare this against my call center design, and I will recreate the diagram. So what it does, it tells me that, okay, these are the different state transitions which are in red, which were in the execution, not in the design. The yellow was in the design, but not in the execution. These are the matching states. I can get a very quick summary comparison on a Venn diagram. I can look at the different flows and again see which were matching or not matching. And then, of course, you can come to the flow diagram. So the flow diagram shows you that these yellow steps, validate complaint, although it was there in the design, it wasn't really executed. So every single complaint is going through and getting addressed. And then here we have this entire bunch of steps whereby the customer rejects the solution, and alternate solution is actually provided. That was not there in the design. So why are they doing this? Should it be there? Shouldn't it be there? People always like to look at this against the original diagram. So what we can do is we can swap and load this, and then we can see the actual comparison against your original BPM and map diagram, because a process analyst or a business user may not like to see a randomly generated diagram. So here you can actually see that these steps are actually not executed, and between these two steps there are some other steps which haven't been there. So this is the first analytic, what we call, it's the compliance analytic. From here we'll move on to the actual data or the path analysis. We can see here there are 10 unique paths for my data set of 3,000 transactions. And let's run some analysis on the total data set. So the first thing we will do is try and understand correlation between the different numeric data sets. So, and the whole purpose of these analytics is built in. You don't have to be a data scientist. If you're a business user, you can very quickly click on the analytics and it guides you into getting some results. So here I can see that, okay, between my customer satisfaction and my satisfaction on response time, 70% correlation, and almost the same on the resolution time. But let's say I know I am having a problem with baggage-related problems. What I can do is I can simply select baggage-related problems, and I can now reload this. So you can see that, okay, people are not so satisfied with the resolution time of baggage-related problems. People get cranky when their baggage is lost. So it's happened to me, so I understand that. So maybe they want to find out. So let's chase this data trail and see what else we can find out about this. We'll now go into the box plot data. So the box plot again gives you some statistics, and again we'll take satisfaction on response, resolution time. So here you can see that, okay, response time, there's a wide range between 100% and the minimum 10%. Resolution time, again, 110. But again, overall customer satisfaction, most of them are within a more of a narrower range. We can then go and filter this down. So let's say I want to filter this and look at entertainment on board. Okay, so I came on a very long flight here. So if my entertainment wasn't working, I would definitely be cranky. So then it would, you can actually see that it's in a much narrower range here. So you can do what we call contextual analytics, and analytics within analytics. We can filter the data, and from there we can get better insights into what has happened. Now let's look at some of the paths here. We can see these paths, and I know that in this fourth path here, okay, the customer's rejected the solution. We've offered him an alternate solution, but he's rejected that too. So maybe that's the data set I want to find out as to why they are rejecting the solution, or what are the types of problems which are being rejected. So I will click on this, and it will drill down into the 338 transactions, and we can see the path here. And we'll do the analytics within the path now. So the first thing we want to find out is the cause and effect between, let's say, the different sectors and the type of problems in the sector here. So which is subtype in mind. So this takes maybe around 15-20 seconds to load up because it's on my local. But what it will tell you is which sectors had the same type of problems and what type of problems then occurred together. So think about it in a call center. You want to start creating solutions to solve these problems. The call center is your front end with the business. So here very quickly we have all the sectors here, and we can see baggage-related problems. And if I quickly sort, you can see baggage-related problems happened on these sectors, and these are all the different problems. So on my data set, I can look at the count, and you can see that US Dubai had the most problems here. And if I filter by the type of problems, you have here canceled flights not leading to missing of an event. That's the categorization. So 10% of those, and 10% of communication with flight and staff behavior. So you can start looking at why people were not happy and why the solution was rejected. Maybe somebody was mean. Now, interestingly, we start coming to the row affinity. So the row affinity starts telling us, if we look at the different colors, you'll see that between Dubai and Christchurch and Dubai and UK, there's a 66% affinity of the problem. So maybe there is something on those two sectors which is common, which you can then start looking at. And if I go to the column affinity, you see baggage-related problems, almost a 34% impact of, let's say, between baggage-related problems and canceled flights. So maybe the baggage gets lost. So we can again filter that and say that, okay, there's a lot of white noise there. Show me just baggage-related problems and canceled flights, and we can come back here and simply regenerate the data set for a smaller and more focused look as to what's happening. And then you can immediately see the correlations here. So you can see that, okay, when a flight is canceled and people complain they are not missing an event, they probably stay on the flight and the baggage gets lost. Whereas if a flight is canceled and they are missing an event, like if I'm coming to BPA next, I'll find another flight and go. So maybe there's no baggage to get lost here. So you can start getting some sort of insights into exactly what's really happening in terms of the data. Now let's go back in here, since this is our area of interest, and we will start running what we call the DNA analysis. So the DNA analysis really helps us to chase paths. So in this case, I want to find out the different sectors we are talking about the type of issues we have, and were they controllable or were they not controllable. So things which are not controllable, like weather and stuff like that, maybe you don't really want to bother about that. But if it was controllable, that's the one you really want to look at. So although I chose, let's say, sector to controllability, what the algorithm has done is there are 20 possible paths which have been detected. So I can actually slice and dice those relationships and look at different aspects of that. And that really gives you different sort of insights into what's happening. And of course, here I can choose the sector scale. So it'll say, show me for the sector scale, show me the total customer satisfaction on that sector, based on whatever transactions are there. So it'll be obviously more than 100 in cases where there are more than, for example, 1. So you can start seeing now that there is a very large matrix of relationships here. And at any point of time, if I want to say, okay, meals on board here, I can click on this and immediately it'll filter out the data here. I can go into what is called the forward matrix to show what was controllable or not controllable, and the backward matrix. So we can always come back to the matrix, which is really the point of the relationship. So this is a graph database at the back which is making the relationships. And again, I think one of the most powerful parts of Wizly is that I can filter this. So let's say I don't want to see anything which is uncontrollable or partly controllable, but only the controllable data set. So I can very quickly reload the data, and you can start seeing now a much smaller, let's say, DNA diagram here. And if I zoom in here and I look at, let's say, baggage-related problems, you will see baggage-related problems happened on these sectors, and these were the customer, let's say, customer satisfaction scores which were then available here. So within Wizly, it's very important to understand that the end user or the business user can very quickly filter the data set here based on as though it's in an Excel sheet. I can click on this, and if I need to group by type, I can very quickly group by type. So it's as though you're working in a pivot table, and then as you generate the data, then all the analytics come up. So we've tried to keep the simplicity of working with a sort of Excel type interface, and then click the button, and then the analytics then come up. So not to have to be a data scientist to use sort of something like this. Now let's look at one last analytic, which we call the 4-box wizard. So the 4-box wizard allows us to, again, we'll plot different sectors, and we look at overall customer satisfaction, let's say the time cost, and we are giving compensation to customers when there are issues there. So what this allows us to do for this reduced data set, we can actually visualize all the cases across here, and I can look at, okay, the cases where the time cost was high and the customer satisfaction was low, and we can very quickly zoom in here, and you can start seeing, okay, this guy, case 1412, Dubai, Mumbai, the satisfaction was low. You paid him a compensation cost of, let's say, $800 or whatever it was. You can also filter this data, and like I said, you only want to see, for example, places where you paid compensation and there is baggage-related problems. So I can go back here and understand and just say, okay, I just want to see the baggage-related problems. And then when I go back and I regenerate, you'll get a very clear picture of a particular problem. So it allows you to focus through all the noise, and you understand, in this case, okay, this guy, Dubai, Tokyo, you paid him $200, he was happy, he probably bought something new, and so that's why he gave a 91 score. But maybe this guy, okay, or this guy, you want to actually go and look at the case number. So case 2745, we can quickly go here and filter down to the case, and let's say case 2745, okay, and we can actually see all the case attributes and understand, was it the person who it was assigned to, was that why the case went? So you can actually go down to the root cause and start doing, let's say, intelligent questioning as to how to improve the case data from the cases from the case data here. So very quickly, I've gone through, pretty much whatever analytics I have time and whatever would run locally on my computer. Of course, it's much faster, and you can run larger loads when you're actually running it on a server, but because of the network issues, I made sure I ran it from the local data set. I'm open to questions right now.
And show them the parent screen with the analytics. But
yeah,
Wizly has about 18 analytics. We're adding 2 more. It'll have 20 analytics. And it's interesting to look at this because this is the process template for Wizly that we've designed. We're working on templates for master data management and profiling. We're working on templates for how you analyze the locations in an enterprise, how you would analyze the documents in an enterprise, okay? So it has a broader application than just processes, but right now, most of the use people are putting it to is analyzing their operational data, basically their processes that they're running. So those of you who have seen the past presentations know we have a fairly large analytic suite with this, with the product. And Jude will show you that real quick.
Yeah. We can take questions while this is loading up. So.
Yeah, any questions? Jude's organization actually does the implementation. Gil and I do the intellectual property. That is, we design the algorithms and everything else for this, pretty much. That's why we're 3 of us up here. And there's a long history on the predecessor that has been used for a long time.
So
these are some of the analytics that you have in the product. There's quite an extensive suite of analytics depending on what you're doing. If you're analyzing things that are at the edge, for example, sensor data, there's binary correlation capabilities within this to take a look at binary sets of data, on, off, yes, no, stuff like that. So there's, these things are very practical. These are things that we've used in analysis for the last 25 to 30 years. And we know they work. We know users are familiar with them. That's another thing. If you look at the affinity analysis and you explain, well, this is how you would tell somebody, people who bought this book also bought that book, aha. Everybody's done that on Amazon. So they're familiar with affinity immediately, even though they don't know the algorithm. They know what it's for. And that's the point. The point is to know what these analytics are for, not necessarily the details of that. You're not, Data Robot has what, 125 to 150 machine learning algorithms. Okay, who's going to know all that? And who's going to hire the people that have the detailed knowledge of that? Most companies are not going to do that. Okay, they're going to go through for something much more simple. Like we're seeing today. We're seeing a lot more of that in today's presentations. Any questions?
Another point is that we're trying to make sure that we could target the analyst or a manager where the information sits right in front of the manager. For the box plot, for example, the simple diagram shows you some form of the distribution of a problem. As a manager, I want to know why I had an extreme on the bottom or why I had an extreme on the top, and how do I solve that? So this is the way we're trying to target some of the graphics behind our analysis.
yeah, question.
Just speak loudly.
Yeah.
So for the BPMN part, how the data is gathered, like you have all detail of every steps, data correlated with that. Do I need to install something with your?
We can just import the case data either from CSV, or we can plug straight into the application through a web service and pull it.
So
It is pulled from data logs.
Yeah.
So, well, the BPM has to log everything with data, so
Yeah.
you can manage it. Now, in the analysis, that there's a mismatch between BPM and what really happened. I don't understand if there is a BPM, how you can go away and not do the BPM.
Well, and I'll tell you my experience on that. A lot of times processes are, and we work extensively in government, the users think the process works like this, but the process actually works differently. And that's what we are trying to find out here. So the design process is different from the executed process. It's not always the same. And that could be because the executed process has changed because of some, let's say, some real reasons or rational, and the design process has not been updated, or the design process has been updated, but the executed process hasn't been implemented correctly. And we've seen many cases of that.
The only place you tend to find these things accurately represented, for example, from policies and procedures, tend to be in regulated industries like banking. Then the procedure for something and the actual execution process are very close. We've done, historically we've done close to 50 projects, and the only ones that have been reasonably close have been the ones that were regulated. All the other ones, Some of them are 8, 10 years out of date. Like I was in oil and gas, we were doing an analysis of their procedures versus the actual execution, and there was like 30, 40% difference. They were huge. And they said, aha, that's why they're having problems, because they're managing from the procedure, not managing from what's actually being executed. Once they see what's actually being executed, then they have to align this. Plus, we get questions of, like we have now, there's 3 banks that are merging. How are they going to consolidate the processes? Well, you use these comparative analytics to compare the processes to know where your core is. And then you have to say, okay, are they 3 of the same kind of banks, or are they 3 different banks? Is one a retail? Is one wholesale? Is one a mortgage firm? Because you're not going to have a lot of similarity between them. Do you have a demand deposit accounting system? You know, so if they're similar banks, then you're going to look for economies of scale. And I know that when you're acquiring banks generally in the same market. And so that you're looking for the similarity of processes. We did this with auditing firms also. A very large company acquired 6 smaller auditing firms, and found that each one had a variation of process. Although the auditing was correct, there was such a variation that they couldn't predict their profitability. So what they wanted was to standardize across all 6 companies. So you do a comparative analysis. Guess what the estimate was to do this? There were 100 processes, 100 to 110 processes in each organization. I made 600 processes. The estimate to do this by hand was 30 million. With the tool, it was about 5 million. It's a huge savings in analysis. So if you're consolidating, when you're doing this type of work, particularly with processes, the semantic analysis, quantitative analysis, the type of algorithms are really critical. Cost effective. Yeah. Did it help? Okay.
Any other questions?
That scared everybody off. I can go into detail on the algorithms that'll put you to sleep. On the other hand, we're close to wine.
Exactly.
We've got 1 session left, so.
Thank you.
Okay,
Thank
great.
you, everybody.
Well, thank you very much.